In this video, I'll be solving question 1 in the Corbettmaths worksheet, changing the subject advanced. So question 1 involves rearranging formulae that you want to get x the subject of the formula. So if we look at 1a, we have a equals a half, and in brackets x plus y. So the thing you want to be looking at each time, the golden rule is whatever you do to one side of the equation, you must do to the other. And we want to do things in reverse, really, from what is actually happening in the equation. So here in the equation, if you had x, you were given that value, you would add y, and then you would multiply by a half. So we want to do the reverse of that. So the opposite of multiplying by a half, and then the opposite of adding y. So the first step here will be to get rid of the half. Now, we could divide by half, but actually, probably better than that is actually just to multiply by 2. It's the same thing, but it just keeps the maths a lot easier. So here I've multiplied by 2, and here I've multiplied by 2. So that gives me 2a on the left and x plus y on the right. I don't need to have the brackets on there anymore because they're the only two terms there. Then I need to subtract y from both sides, because that will then isolate the x term. So on the left-hand side, I have 2a minus y, and on the right-hand side, I have x. And normally, it's neat to write it the other way around, so x equals 2a minus y, but there is nothing wrong with leaving it in this form here. On part B, we're looking for isolating x, and we have a equals pi r squared plus 2 pi r x. So one way of doing this is you could say, let's subtract pi r squared from both sides. So I'm going to subtract pi r squared from there and subtract pi r squared from here. That's going to give me on the left-hand side a minus pi r squared equal to 2 pi r x. When we look at this equation now, we have x and it's being multiplied by 2 pi r. So I will just divide by 2 pi r, and that will isolate x on its own. Obviously I have to do the same on the left-hand side, so divide by 2 pi r, and I have a minus pi r squared over 2 pi r. And again, if you can write it any other way if you want to, so x equals a minus pi r squared. It just looks a bit neater with the isolated term on the left-hand side there. There is an alternative way of doing it where you would factorize first with pi and r, but to be honest, that's not going to make it any easier to actually work with. So I think this is probably the clearest and quickest method to solve. For C, we have t equals 3x squared minus y. Again, we are isolating for x. And looking at this, what you've got here, you've got one term here, 3x squared, and then you're subtracting y. So let's isolate this 3x squared term first by adding y to both sides. So on the left-hand side will become t plus y, and the right-hand side is going to be 3x squared. Now, I want to isolate my x squared term. That's the part that actually has the x inside. It's being multiplied by 3, so I will divide by 3. I'm going to divide the left-hand side by 3, so I'm going to actually put that in a bracket to show it's together, over 3, and that's equal to x squared. One more step. X is being squared. Opposite of squaring is square rooting. So if I square root the right-hand side, I get x, and I put the whole of the left-hand side under the square root. You don't necessarily need the brackets on there. I just think it's a bit neater if you do. But if you wanted to, you can actually perform the entire question without putting the brackets in on here or here. But do make sure that your t plus y at this stage is completely over the fraction. And here the root completely encloses the entire fraction here. For part D, we have s equals m over ax. Now here our unknown, or the term we want to isolate rather, is within the denominator of the fraction. That's not very nice. That kind of messes things up. So what we want to do is get rid of that. We want to say, let's get the x term, or the term enclosing x, up. So it's not the denominator. So what I'm going to do is I'm going to multiply both sides by ax squared. So on the left-hand side then, I've got my s, and I'm multiplying by ax. And on the right-hand side, I've got m. So all I've done here is I've multiplied this by ax, leaving me with m, and this by ax to give me sax. Now I want to isolate x, so I need to divide by s and a. So if I divide by s and a, we're going to go m over sa, and to be honest, probably in the book, if you're doing this as an exercise, you would probably see the a and the s reversed. Alphabetical order is always nicer when things are multiplied in algebra. So x equals m over as, although the first version here, this one here, is still valid as well. The point to note with this is when our unknown that we want to isolate is at the bottom of the fraction, it makes sense to first of all get it away from the denominator, get it on top. And in this case, by multiplying both sides, it comes over to the left-hand side. Okay, in E, we have x embedded in one of these terms here. S equals uy plus a half xy squared. First of all, we want to isolate just the term which involves the x. So we want to get rid of this uy. Because it's being added, we must subtract. So if we subtract uy from both sides, we have s minus uy equals 1/2 xy squared. Now I'm going to get rid of the half next and leave the xy squared alone. So to do that, I'm going to multiply by 2. If I multiply by 2 on the right-hand side, I will get xy squared. Multiply by 2 on the left-hand side, I'm going to have 2, and I must use a bracket here, s minus uy. I have to use a bracket because all of this left-hand side is multiplied by 2. Finally, on here we've got our x, and it's multiplied by y squared. So to isolate x, we need to divide by y squared. So if I divide by y squared on the right, I get x. On the left, it's the whole thing divided by y squared. The thing to note here is that the 2 bracket s minus uy, close bracket, all of that is over the fraction, is the numerator, and y squared is clearly the denominator. And again, you could have put x on this side and then 2 s minus uy over y squared on this side. Okay, next one, f. X is here. We've got to be careful, we've got 2 fractions going on, so that could kind of mess things up. But the first thing we want to do here is say, well, we have our term involving x, and we have a t added on, so let's get rid of that. That way we isolate the term with the x. So I'm going to subtract t from both sides. So I get 1/3 w minus t equals 1/4 x. Now, we want to have just a single x on the right-hand side, so to get to that point, we have to multiply by 4. Multiplying a quarter, x by 4 would just give us x. So we multiply the left-hand side also by 4. It's the whole thing on the left-hand side. So I'm going to put my third w minus t inside a bracket. I'm going to multiply by 4. It's a little bit messy with the fraction in there, so I'm actually just going to take it one step further, leave my x alone, but just expand the bracket. So I'm going to get 4/3 w minus 4t. That version there is neater, I think, than this one, although both are correct. In G, we have j equals x plus 3 over d. X is the thing we're trying to isolate. Let's get rid of this fraction first, get rid of this d. So d is the divisor here, so we will multiply both sides by d. That will give us dj on the left-hand side and x plus 3. Note what I did here was I put these in alphabetical order. Don't have to, I could have left it as jd, but we really should. It's good convention to put the letters when they're multiplied alphabetical order, so dj. X is what we want, is having 3 added to it, so we should subtract 3. X on the right-hand side, dj minus 3 on the left-hand side. And h, our isolating term here is on the denominator. So as previously, we want to get this term away from the denominator. So we're going to multiply by x minus 2. I'm going to treat that as one entire thing. You cannot do it in isolation, okay? So I multiply both sides by x minus 2. So the left-hand side becomes g, x minus 2. And the right-hand side is then just t. Now I need to isolate the term with x minus 2. So I have x minus 2 equals t, and that's divided by g. I've divided the left-hand side by g, so the g goes from here. And I divide this side by g, so the g becomes the denominator. Finally, isolate x on its own, so I need to add 2 to both sides. So I will have x equals t over g add 2. So take a moment to look at that one. It's important really to note that the x minus 2 is an entire thing, so worth putting it in brackets. Get that term multiplied on both sides, so it becomes up the top here. We now don't have a fraction on this point. We don't expand this bracket because we can just divide by g to pull it down to here. And then finally we isolate the x by adding 2 on, and that's added to the whole fraction. You don't need to put that inside brackets. Just make sure the plus 2 is outside of the fraction itself. And next we've got p equals 3 brackets y plus 2x squared. So I'm going to get rid of the 3 first because that's the easy bit. So I'm just going to divide by 3. So it's p over 3 equals y plus 2x squared. Now it might be tempted to say let's square root. And we can do, so let's try that. Square root of p over 3 will be equal to y plus 2x. Then what you might want to do is say, well, let's subtract y. So it's the root of p over 3, and the whole thing we subtract y. So keep that outside, well away from the root in a way, equals 2x. Then we divide by 2. So x is going to be the root of p over 3 minus y, and the whole thing is over 2. Not a particularly pretty equation, certainly not one easy to use, but we have at least isolated the x term. Looking at j, we have 12w equals 3/4 and then brackets 2x plus a. We want to get rid of the 3/4. I'm going to do it in 2 stages. First of all, I'm going to multiply both sides by 4. So if I multiply both sides by 4, I'm going to get 48 on the left-hand side, 48w, and I'm going to get 3 bracket 2x plus a. The next stage is to divide by 3. So that's going to give me 16w on the left-hand side, and then just 2x plus a. At this stage, I can remove my brackets. I want to isolate the term involving x, so I'm going to subtract a. So 2x equals 16w subtract a. And then finally, I think it's going to be divided by 2, so x equals 16w minus a over 2. Now you could, if you wanted to, go to another stage and say, well, let's make that a little bit easier, and we'll do the 16w divided by 2, which is 8w, and then we just have a half a, or a over 2. To be honest, either answer is correct. They both have isolated x. Probably the last one is a simpler one to actually consider. So in conclusion, when you are asked to isolate or make a different variable the subject of the formula, you want to be identifying and isolating the terms that involve your variable, and quite often you do it step by step. So you don't just consider the x initially on its own in these cases. You look for the term that actually has the x within, and then you isolate down and down and down until it is on its own. Quite often we are doing the opposite functions. So instead of multiplying by 3, we divide by 3. And be careful when your variable is the denominator of a fraction. You really want to get that term away from the denominator by multiplying both sides by the denominator.